Picture this. Your next door neighbor is vast and invisible, and it literally swallows everything that gets trapped in its voracious gravitational pull. That would certainly scream a spooky sci-fi film, except this one is a reality. Well, we do say hi to Mr. Moon every night. We've met Jupiter, our solar system's largest planet. We've seen the Carina Nebula, one of the biggest star-forming regions in our galaxy. But have you met the newest addition to the neighborhood? It's close, and it's on our doorstep. Ladies and gentlemen, say hello to Gaia BH1, Earth's nearest black hole. Gaia BH1. Space is full of surprises. Just when you think you've got the universe figured out, it throws you a curveball. It's a new black hole out there, and it's nothing like we've ever seen before. This newly discovered black hole is going to make your head spin. Just when you thought black holes were cool, here comes Gaia BH1, the new record holder for the closest black hole to Earth. In fact, it is 3 times closer than the previous recordist, which is an X-ray binary located in the Monoceros constellation. Apart from that, it is larger than our Sun by 10 times. If 1.3 million Earths could fit inside the Sun, then 13 million Earths could fit inside Gaia BH1. Just imagine how massive it is. Gaia BH1 is located in the constellation of Fucus and can be found 1,600 light-years away from our solar system. This black hole is so close that the National Science Foundation's Noir Lab Astronomy Observatory refers to it as being in our cosmic backyard. Black hole. When you think of a black hole, you might imagine something like the one in Interstellar, sucking up everything in its path. Black holes are the ultimate cosmic enigma. They're objects with so much mass that they pull in everything around them. Literally everything. They're created when stars die, collapsing under their own gravity until they become so dense that nothing can escape their grasp, not even light itself. Black holes are basically giant cosmic vacuum cleaners that suck all matter into their hungry maws until only an abyss remains. Except now we know where this one resides. But don't worry, it's not going to swallow us up or anything like that. How did they discover it? The discovery was made possible by the Gaia satellite, which has been mapping the positions and motions of billions of stars in our galaxy since it was launched in 2013. This mission is set to last until December 31st, 2025, 12 years after its launch. The Gaia satellite is also mapping the distances between stars and how they move over time. Data from the Gaia spacecraft of the European Space Agency were initially examined by the researchers to determine the system's potential presence of a black hole. Gaia captured the tiniest changes in the star's velocity brought on by an invisible massive object. This new discovery has also been backed up when researchers used the Gemini North telescope in Hawaii. It's one of the twin telescopes of the International Gemini Observatory, which is run by the NSF's National Optical Infrared Astronomy Research Lab. Our Gemini follow-up observations confirm beyond reasonable doubt that the binary contains a normal star and at least one dormant black hole. El Badri, one of the researchers, shared. El Badri and his team used the Gemini multi-object spectrograph instrument on Gemini North to analyze the system in greater detail. This device accurately determined the companion star's orbital period by measuring the companion star's velocity as it circled the black hole. In the paper published in the monthly notices of the Royal Astronomical Society, researchers used this data to find evidence for a black hole that was previously thought to be a star. The researchers even wrote, "We identified the system as a black hole candidate via its astrometric orbital solution from the Gaia mission. Radial velocities validated and refined the Gaia solution, and the spectroscopy ruled out significant light contributions from another star." In layman's terms, the star had a characteristic wobble, indicating that something was pulling on it. It turns out that it was the dormant black hole. Dormant black hole. Dormant black holes are the perfect place to hide if you're a supervillain. Well, maybe not, but they're certainly interesting. The only problem is that these dormant black holes are really hard to spot. They're kind of like one of the best-kept secrets in the universe, but scientists are here to tell you about them anyway. It has been confirmed that a dormant stellar mass black hole exists in the Milky Way for the first time. Since they do not interact much with their surroundings, they are particularly difficult to identify. They're kind of like a dormant volcano. You know, it's there waiting for its moment to erupt. This is due to the fact that dormant black holes, in contrast to most black holes, don't release a lot of X-ray radiation. This makes it hard for us to detect them when they aren't actively consuming matter or emitting radiation. But it's just as true that these black holes are also less likely to destroy any planets or stars around them while they're at it. Binary system. Just when you thought Gaia BH1 wouldn't get any more interesting, the closest black hole here to Earth is not alone. Scientists have found out that it is part of a binary system. A binary system is one in which two astronomical objects orbit each other. It's like the yin and yang. For a better picture of Gaia BH1's binary system, take the solar system, put a black hole where the sun is, and the sun where the Earth is, and you get the system, described Kareem El-Badri, an astrophysicist of Harvard and lead author of the research study. So when we talk about binary systems, we're talking about a whole lot of things at once. Gravity, orbits, the laws of physics, all that good stuff. But what further makes it exciting is that while there have been many claimed detections of systems like this, almost all these discoveries have subsequently been refuted. This is the first unambiguous detection of a sun-like star in a wide orbit around a stellar mass black hole in our galaxy, El-Badri added. With an eccentricity of 0.45 and a period of 185.59 days, the star and black hole orbit one another. The orbital period is longer than those of any other stellar mass black hole binary known to science. The system's low eccentricity, high metallicity, and thin disk galactic orbit imply that it was born with only a weak needle kick in the Milky Way disk. Mysteries of the Earth's closest black hole. Gaia BH1 is a system that's relatively close to us, and it's intriguing for various reasons. It is puzzling as the researchers don't know how the star and black hole ended up where they did. A star that has created a black hole is referred to as a progenitor neutron star. The progenitor star, which later evolved into the newly discovered black hole, would have had a mass at least 20 times that of the Sun. This implies that it wouldn't have lasted more than a few million years. If both stars had formed simultaneously, this enormous star would have quickly evolved into a supergiant, inflating and swallowing the second star before it had a chance to develop into a proper main-sequence star like our Sun, which burns hydrogen. As shown by the observations of the black hole binary, it is astonishingly unclear how the solar mass star could have survived that incident and ended up as a seemingly normal star. At the very least, the companion star should have been pulled into a considerably closer orbit. El-Badri continued by saying that it is interesting that this system is not easily accommodated by standard binary evolution models. It poses many questions about how this binary system was formed, as well as how many of these dormant black holes there are out there. What now? The recent discovery of Gaia BH1 is definitely a big deal. It's a black hole in a binary system that's actually near our galaxy, and we now know that there are more of these systems out there than we had previously thought. Gaia BH1 is a fascinating discovery and has provided us with new insights into black hole formation and evolution. This may suggest that there are noteworthy knowledge gaps regarding the formation and evolution of black holes in binary systems, as well as the existence of an undiscovered population of dormant black holes in binary systems. It's possible that studying these systems will help us learn more about how black holes interact with their surrounding environments, and maybe even give us a better understanding of how our own galaxy formed. It's clear that we still have a lot to learn about black holes and binary systems, but what's exciting about this discovery is that it may lead to more discoveries. What other mysteries are waiting for us? For now, we can only speculate, but that's part of the fun. Hello from Earth, Gaia BH1, and a warm welcome to the neighborhood.